All right, let's talk about a classic developer headache. One of those mysteries that drives teams crazy because it just seems to pop up out of nowhere.
You know the drill, right? Everything's running great on your machine, your little test database is happy, and then you push to production. Real data, real users, and suddenly performance just tanks. It is so frustrating, but the answer? It's usually hiding in plain sight.
So let's get right to it. We're going to dig into how Spring Data JPA, the tool that's supposed to make our lives easier, can actually be hiding some nasty performance traps. We'll see how tiny, innocent-looking choices in your code can have this huge ripple effect on your app's speed.
So to really get this, we've got to zoom way in. We're talking about the most basic thing we do, saving or updating data. Because right here, in this simple act, is where one of the biggest and most common traps is waiting for us.
Okay, so here's a really common one. A lot of us, especially when we're in a loop, we reach for save and flush. I mean, it makes sense, right? I just changed this thing, I should probably save it right now. But, and this is a big but, that kind of thinking totally works against the magic that makes JPA so fast.
And as Thorben Jansen points out, what you're really doing is you're basically yelling at your database with every single little change. Instead of letting JPA be smart, bundle up all those updates and send them over in one neat package. You're forcing it to have a whole separate, expensive conversation for every single item in that loop.
And just look at the difference here. It's so clear. On the left, there's that save and flush call inside the loop. But check out the right side. The code just changes the object and that's it. It just moves on. Why? Because these are what we call managed entities. They're inside a transaction, so JPA's dirty checking feature is watching them, is smart enough to see, hey, this changed, and it'll handle all the SQL updates for you when the whole thing commits. You're letting the framework do its job.
And wow, this chart just lays it all out. The logs do not lie. To update just 4 little entities, the wrong approach forced 5 different flushes. The right way? Just one. A single, clean flush at the very end. That's a 5-to-1 difference, and you can imagine how that explodes when you have hundreds or thousands of records.
Okay, so that was all about writing data. Now, let's flip the coin and talk about reading data, because this is where we find one of the most notorious performance killers out there.
So, have you ever been looking at your logs and you just see this waterfall of SQL queries scrolling by when you were really only expecting 1 or 2? If so, congratulations, you've met the N+1 selects problem. It is a true silent killer for performance.
So here's how this monster works. First, your code fires off one query to get a list of things. Let's say a list of players. That's the one. Then, you start looping through those players. And for every single player, you try to access something related to them, like their list of tournaments. And bam, JPA fires another query, and another, and another. One for every single player. That's the plus N. One query to start, plus N more query.
And this is what your log file ends up looking like. Just a mess. A flood of individual select statements. Each one of those is a whole round trip to the database, which is expensive. So if you've got 100 players, you're not making one database call, you're making 101 of them. Ouch.
The good news is the fix is actually pretty straightforward in concept. All you have to do is tell JPA up front what you're going to need. The @EntityGraph annotation is perfect for this. It's like leaving a note for JPA that says, hey, when you go get those players, could you also grab their tournaments at the same time? Thanks. A join fetch in your query does the same thing.
And what's the result? Well, your log file goes from that ugly mess to this, one beautiful, clean SQL statement. It uses a join to get everything it needs in one shot. I'm not exaggerating when I say the performance difference here is like night and day, especially when you're dealing with a lot of data.
Okay, so we've got these 2 big culprits, inefficient writes and super chatty reads. But you might be thinking, okay, are these really that big of a deal? And the answer is yes, because it all depends on the bigger picture. The architecture you're building in can take these small problems and blow them up into huge ones.
Here's the deal. In a good old-fashioned monolith, a bad query is slow, but maybe you don't notice it too much. The database is right there. But in the world of microservices, that same bad query can be absolutely catastrophic.
So why is that? It all comes down to one thing, the network. In a monolith, everything's in one big box. If one part needs to talk to another, it's a super fast in-memory call. But with microservices, all those little services are talking to each other over a network. And network calls are slow, way slow.
And that is the magnifying glass. Suddenly, every single one of those extra plus N queries isn't just a quick database hit, it's a slow, painful trip across the network. A problem that was just a tiny blip on the radar in a monolith can now bring your whole distributed system to its knees. Seriously. Efficiency stops being a nice-to-have and becomes an absolute must for survival.
So, what do we do with all this? Well, here are the key takeaways. First, you have to watch your queries. You can't fix what you don't know is broken, so turn on that SQL logging in def. Second, write smarter. Let the framework do its job. Don't force flushes in a loop. Third, fetch your data efficiently. Hunt down and kill those n+1 problems with things like @EntityGraph. And last, always think about scale. Just because something works in a monolith doesn't mean it won't crash and burn in a microservices architecture.
Look, performance isn't just an afterthought you tack on at the end. It's a core feature. So think about the code you're working on right now. Now do you know what to look for? Those sneaky save and flush calls, those n+1 query storms. What's the very first bottleneck you're going to go fix tomorrow?